Welcome to the next part of Nanoindenter training. In this part, we are going to open up the software, give you a little tour of what's included in the software, and calibrate our tip. So let's first open the software. It's this icon right here, Puma. And I should say that what I have on the instrument right now is a tip that's already loaded and has been wetted. And below that is a glass Petri dish with the solution that I want to make my measurement in. You need to calibrate your tip in that same solution. And the very first thing it asks us is, do we want to home the stages? You want to make sure that your tip is far enough away from the glass Petri dish so that if the Petri dish moves in the XY direction, it is not going to hit that tip. So as long as you're comfortable, then you can go ahead and hit yes. And it's going to move the stages, you can hear it, in X and Y to its limits. And then it essentially positions the stage so that we are in this corner of the total stage travel. The stage can move 12 millimeters by 12 millimeters. And I really don't like to start my experiment in the corner. I'd rather be closer to the center. So I'm going to use this manual feature to move in X, Y, and Z and tell it I want to move 600 microns or 6 millimeters in X and also in Y. And now we're starting our experiment in the middle of the stage travel, and I have a little bit more freedom in terms of what direction I want to move. So let me give you a little bit of an overview of the software before we do our next steps. This here is a camera. You'll be able to see the tip come in from the top, but it is a little bit difficult to use this camera to see your sample. If you do want to do that, you may have to prop your sample up a little bit. Talk to me if you're interested in doing that, and we can discuss further. I've already kind of shown you the X, Y, and Z manual stage controls that you can use here. These are sometimes useful for getting our tip into solution and also adjusting the XY position of our sample if needed. Down below that are some buttons that we're going to use later on, especially find surface and run experiment. Over here, it's showing us some of the XYZ positions, the current positions, and also the location of the surface. Once we find a surface, this will read a number. So that you can use that as a reference. Over on the right side of the screen, this is where we're going to see our data. You'll see that in a minute. And then down here is kind of a real-time display of what's going on with both the piezo that moves everything up and down, and then what's actually happening at the cantilever. At the bottom of the software, it kind of shows the states of all the different components of the instrument. A lot of them right now are idle, but when we are doing a measurement, you'll see that they will say something else and will indicate that they are actively doing something. In the bottom right-hand corner, there's a little box. You want that to be green. If it's not, there's likely an error message that has come up, and you can click on it to see what the last steps were and what that specific error message was. At the top of the page, it also indicates its current status. So right now it's idle, but when we are approaching the surface or making a measurement, it'll say something else. And this, along with these buttons at the bottom, will help you determine when it has finished doing whatever you've asked it to do. There are also buttons in the top right-hand corner that we will use to run our experiment. And so we're going to start up there now with this calibrate button. And so in order to do a calibration, we need to make sure that the tip is submerged in the liquid that you're going to make your measurement in. So I like to make sure that there's plenty of liquid in my Petri dish so that I can comfortably get the tip underneath the liquid and not fear crashing the tip into the bottom of the Petri dish. So I use the controller knobs on the side of the instrument to move the tip down, but I've moved it all the way down and it's still not in the liquid. So now I'm going to be somewhat cautious and only move 300 microns at a time down towards the liquid. And when I do hit the liquid, we'll probably see the image here change just a little bit. There we go. You can see some interesting reflections, and this is actually my tip at the very top. Now I do want to make sure that I'm well submerged, so I'm gonna go down maybe a few more. And again, I am doing this all by eye, essentially. Looking at where the surface of the liquid is, where the bottom of my Petri dish is, and how comfortable am I moving that tip down. Remember, these tips are somewhat expensive, and you're gonna buy them, or at least your PI is gonna buy them. And you can use them for a really long time if you don't crash them into a surface. So it's good to be cautious. So I think I'm well submerged now. I'm gonna come up to this calibration button, and I'm gonna start the first part of the calibration. Now when I do this, we're gonna see some changes in this window, this kind of live time window down here. We're gonna see something that looks kind of like a sine wave, kind of a pixelated sine wave. That's normal, that's what you wanna see. If you don't see that, there's probably something wrong with your tip. So I would first make sure it's submerged in the liquid, that it's not in contact with the glass. Did you recently bump it? Could your tip be gone? Those are the things I would start to ask myself if I did not see the sine wave. Now also on the front of the interferometer, I have a little progress bar, and it's telling me what it's doing and how far along it is in the progression. So both of these things tell me that it's currently doing this action. And now at this point, it is finished. The sine wave has gone away, and my progress bar on the interferometer is also gone. So now we can come to the next step, which is find surface. This find surface button is a little bit different than the other find surface button. In this case, I want to find the surface and then stay in contact with it. So in this case, it's going to find that surface and stay engaged on the surface. This other find surface button is going to find the surface and then lift the tip a certain distance off the surface, and we can specify that distance. I'll show you where that is later. So let's go ahead and find surface. We are going to see some changes in our graph down here, indicating that the tip is approaching the glass, and this is an automated function. So it can sense when it is getting close to the surface and when it's actually in contact. So right there is a little feature that it saw, and we are now in contact with the surface. I can now come back to the calibrate and press the calibrate button. It wants me to double check I'm in contact with a stiff surface. And as long as you've gone through the calibration functions as I've described them, you should be fine. You just press OK. And it's going to do 2 force curves for us on this glass surface. And you can see at the bottom that it is telling you it's actively doing something. Also at the top, it says it's calibrating. These are your indications that it's actively doing something. And you'll see that when it finishes, it'll go back to that idle state. Great. So you can see here, these are called geofactors. They're geometric factors, essentially, that change a little bit depending on the solution that you are using and the temperature of that solution. And so you see that our geofactor has changed just a little bit from the last time I calibrated. And yes, I want to save this new factor. Now, this factor is saved under the probe portion of the software. You can see that it's right here. Now, these other 2 numbers are numbers that are on the front of the box that your tip came in. And so if they are not representing your tip, you need to make sure that you change these values to match what is on the front of the tip box. Once you're finished with that, you can press save. So that's all I'm going to show you in this video. In the next video, we'll start configuring an experiment and taking some data.